All right, someone asked about this problem, area between curves 2, problem 4. Find the area of the triangle with these vertices. Here you can see I've drawn this triangle. Okay, this is the point over 3, up 2, that's 0, 0, and over 1, up 5. Okay, now you can see that I've separated this triangle into two pieces. Area 1, that's the blue, and area 2 is the red. Okay, so the area of the triangle as you can see, the entire area of the area of the entire triangle is equal to A1 plus A2. Okay, so now let's. All right, so now I'm going to label each of these lines, each of these straight lines. Imagine that I've drawn straight lines there. Right, so the straight line from 0, 0 to 1, 5, I'll label that line 1. So L1 for line 1. This line here, I'm going to label L2, and this line here, I'm going to label L3. Okay. So area 1, the blue area there, we can compute this with the integral from 0 to 1. Remember, top minus bottom, so line 1 minus line 3. So L1 minus L3 dx plus area 2 is the integral from 1. Let's see, x goes from 1 to 3. L2 minus L3. All right, so now we just need to figure out what L1, L2, and L3 are. So let's see. Now L1, let's figure that out. Okay, remember a straight line has two things, right? We need a y-intercept and a slope. You can see the y-intercept is 0 here. So that's normally we call, right, y equals mx plus b. You can see that b is 0. Right, so all we need is y equals mx. So we really only need m. All right, so let's figure out what m is. Now remember, you can think of it as m is the rise over the run. Right, so the rise, so how much do we rise? We rise 5 and we run 1. 5 over 1 or 5. So L1 is y equals 5x. And you can just check, you can say, okay, if we started there, we went up 5 and over 1, all right, we would get there. Okay, so that's L1. L1 is 5x. Now let's figure out what L3 is. All right, so again, let's see. You can see that y equals mx plus b. The y-intercept again is 0. So we just need to find the slope. So the rise is 2, the run is 3. So 2/3, so So y equals 2/3 x. And again, you can start at 0 and say, okay, if I went up 2 and over 3, rise 2, run 3, I would get there, okay. So that's 2/3 x dx. Let's see, we didn't figure out L2 yet, right? We just figured out L3, so something minus L3, which is 2/3 x. Okay. Now we just need to figure out what L2 is. Okay, now you can see with L2, right, that the y-intercept is not going to be 0. Okay, so we're going to have to do a little bit more work with L2. All right, first let's figure out the slope. Remember, m you can think of as y2 minus y1, x2 minus x1. Okay, and it doesn't matter which one you choose to be your x1, x1, y1, and x2, y2, just as long as you're consistent. All right, so we might as well just label them. Let's say this will be x1, y1, and this will be x2, y2. Okay, so y2 is 2, minus y1 is 5, x2 was 3, minus x1 was 1. So let's see, 2 minus 5 is negative 3, and 3 minus 1 is 2. All right, so we see that the slope is negative 3/2. Okay, now to find the equation of a line, we can just pick one of the points and use point-slope form. It doesn't matter which one we use, we'll get the same equation. So I'm just going to pick 1, 5. So y minus 5 equals negative 3/2 x minus 1. So y minus 5 equals negative 3/2 x plus 3/2. Now if I add 5 to both sides, let's put that right here. You get y equals negative 3/2 x. So I want to add these guys together. Let's see, I guess go like that. All right, so that's 10 plus 3 is 13. 2. Okay, so L2 is negative 3/2 x plus 13 over 2. Minus 2/3 x. Okay. All right, and so from here now you can compute the integral, take the antiderivative, all that good stuff, and go from there. Right?